Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. I think, yeah, it is an extension of yesterday's question. So, um, so basically, like we want to return like the maximum value over all triplets, ijk, and like they have to be ordered, so like you can't mix them up, such that this is maximized. So like nums I minus nums j times nums k should be maximized. Um, right. So what we want, yeah, okay. So I think like the only difference from yesterday's question is that our bounds is a lot larger. So yesterday I just did the brute force version, so I just like loop through every pair and I just get the max. But today we can't do that anymore. So but I guess like we did kind of look at the solution yesterday. So we do know it is DP. So what I think we have to do is we want to, so I think like we want to get the running max and min, the running max and min for the previous number, and we want to like multiply by, so like basically the DP. I think like it would be better if I give an example. It also like tells me whether I'm getting it right or wrong. So we want, so like let's say we are looking at like 1, right? Well, we want to find the biggest difference we can find from before. So yeah, so my first thought is actually to like just find the maximum and minimum like from before, but actually we can't do that because our maximum number has to be has to be before our like the minimum number that we want. So yeah. Yeah, but I think like for the multiplication part, we can definitely just look at like each of the numbers like we have from the second element on, because like the like k has to be like 2 or bigger, right? Like due to this constraint here. Uh yeah, so that's the first thing we can do. The second thing is we do have to we do have to find a way to like get the maximum difference. So yeah, how do we do that? So let's ignore, I think like maybe we can do one DP first. Or do we need to? Right, so I think like we want a running like max difference. So max difference. And let's just look at like maybe 612 217, something like that. I think it's better than this case here. So when we start at 0. When we look at this, it's still 0. Like we don't really have like the difference. But when we look at 12, well, I guess like maximum difference. Well, because like we want to return 0, like if all the triplets have a negative value, so we can just keep maximum difference to be 0. Yeah. And but then like when we get to 2, I think like we want to, yeah, we can just get the maximum of like the previous element. So we have like the max element here. So what would it be? It would be like 6, and then it will be overwritten by 12, and then like when we get to 2, we won't overwrite it. But then here we can just get the maximum element minus like the current element, right? So we can find like the maximum difference is going to be 10, like so 12 minus 2. And then when we get to 1, well, again, we can just do like the maximum element before minus our current element. So it would be 1. And yes, the maximum difference did increase. But like when we go to 7, it doesn't change this, and it also doesn't change that because like 12 minus 7 is only 5. So yeah, I think we can do something like this, and basically like like we can do that to like find the maximum difference like before the number that we are looking for, and like basically we just want the maximum difference like multiplied by like whatever element we are currently looking at, right? And if we try all of these, we will be trying like all the best cases for each number here. So yeah, I think we can start coding, and then we can like actually work out like where we can actually work out how we should like order like the updates for maximum element and maximum difference. So yeah, definitely need maximum elements. I guess like the maximum element, we will make it. Let's just set it as 0 for now, and then we can work it out. The maximum difference, we will set it as 0 as well. And then now for I in range, so we want to start from the second element. Because like the elements we are looking here are only like these elements, right? And obviously k is like 2 or bigger, like can't be 0 or 1. So what we want to do, we probably like want the max value as well. So when we get to like the first element, so like the first like multiplication element that we can use, I think like we want to look at the previous element for the maximum difference, and we want to look at the second last element, so like 2 elements back for the maximum element. Yeah, so I think what we want to do, we want max element to be, do we get any negative numbers? We don't. So we don't have any edge cases for that. So we want the maximum, like either the current running max, or like two numbers back. The maximum difference is going to be, well, the maximum of the current running difference, or the maximum element minus the previous element that we are looking at. And then the maximum value is going to be, well, again, the running maximum multiplied the current running maximum value, or the current max difference multiplied by our current number. And if we do that, we are guaranteed to exhaust like basically every case. And like the reason like we look 2 numbers back is to like basically when we are looking at the second element, right? The only element that could be the maximum element, like for num's I, is like all the numbers 2 numbers back, right? And like when we look at 3, it's going to be like 0, 1. So like that's why we are looking 2 back. And like similar reasons for nums j, because like the difference has to be like 1 number back at least. So yeah. So I think if we do this and then we return the max value, I think it should work. Okay. Nice. Yeah, I guess like for this one, we did kind of look at the quick solution yesterday, and that's kind of exactly like, it kind of gave away that it is DP. But yeah, I actually don't know how hard it would be to see that this is DP. I guess it's still not too difficult, because it's like very obvious that like looping through all the triplets are way too slow. But then like you only really need to look at the best case. Like in this case, maybe you can get confused like with greedy as well. But yeah, it's a very like clean DP, and yeah. So thanks for watching, and I'll see you tomorrow. Bye.